Let's look at another one of these ESP32 cameras. This is the TTGo camera. It's got a monochrome display, a PIR sensor, and a slot for an SD card. No, it doesn't have a slot for an SD card. And a fisheye lens. What I'm most excited about with this one is that thanks to Pinky Wafer, we already have it ready to work with ESPhome and Home Assistant. So let's check it out. So right now it's advertising on the monochrome display the Wi-Fi access point address. With that and a Wi-Fi device, we can connect to this board and start tinkering with some of the controls. I'm going to use my phone. We'll go to Wi-Fi settings and look for TTGo camera. There it is. Then we need to go to a browser and go to URL 2.2.2.1. I don't want to go through all these settings, but all the settings for the image are available, or a lot of them. Now, I wish there was a way to make it broadcast a URL so we could get this image into something like Home Assistant. I don't see that option. I'm very impressed with the image. Very impressed. All right, we can enroll a face. Oh, no, actually, it's blocked out. Yeah, enroll face is blocked out. So that must mean it doesn't have the ESPhome firmware. Okay. Well, that's pretty good. I think now I'm ready to ditch this, and I'm ready to load ESPhome on it. What do you think? Let's do it. So this is as good a time as any to really try and learn how to back up firmware off of one of these ESP chips. To back up the firmware off of one of these ESP chips, like an ESP32 or an 8266, we're going to use something called ESP Tool. To use ESP Tool, the first thing that you need to do is install Python. So let's do that. This says you can either do Python 3.7 or you can do Python 2. Whatever it is. So let's do 3.7. We'll do the latest version. We're going to download it there, and we're going to install it. I'm going to go ahead and say add Python 3.7 to path. That seems like it would be important. Install now, app local Python. No, I want to install it someplace else. Let's customize it. Location. Everything else is fine. I just want to put it in a different location. There. That's what I want. I think that's fine. Precompile standard library. I don't know. I'll just say yes. Okay, after a minute of installing, you get setup was successful. Close. Let's go to the command line now. So we're going to go to our little window down here. This is on Windows, by the way. And we're going to type CMD. We're going to get a command prompt. Okay. Now we're going to go to the folder where we installed Python. That was on V. It was Python, right? PY3. Great. If we wanted to see what's there, we can do that. This is my old DOS days coming back to me. It's been a while. Next step, we're going to go back to that page where we were following the instructions. Okay, back here. So now we have Python installed. Next step, we're going to pip install ESP Tool. Oh, that looks good. That looks very good. Oh, it says I'm using version 19.03, however 19.1 is available. That's fine. I'm going to actually do it. Python. It's funny, I just installed the latest version. You would think that would be there, but maybe not. You know, it's cool. Whatever. I'm not going to judge. Doing some work. Latest version of pip. I don't think it's going to make any difference in our ESP tool, but there we go. ESP Tool is installed. After installing, you'll have ESPtool.py installed into the default Python executable folder, I'm sure that says. You should be able to run it with the command ESPtool.py. Great. So this is what we were trying to do on that stream that I was just too tired to try and figure out. Learning something new with hundreds of people watching. It's not something I'm afraid of, but it's not something I do very well. I thought there was a command for port list. I just wanted to see what all ports are connected to it. If no -P option or ESP Tool port value is specified, ESP Tool will enumerate all connected serial ports and try each one until it finds an expressive device connected. Oh, well, that's nice. Maybe we don't even have to do that. I'm going to find the port by cheating and using an ESP tool that I know works. We're going to go to ESP Home Flasher, and I know it's going to tell me which port 21. So I know that ESP Tool has a command that will tell you which port it is. I just don't know which command it is. But now we know that it's port 21, and that's all we really need. So what I want to do is write the flash. I want to read the flash and put it in a file. That's what I'm going to do. Read flash, yeah. The read flash command allows reading back the contents of flash. The arguments to the command are an address, a size, and a file name to dump the output to. For example, to read a full 2 megabyte attached flash, blah, 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 blah. I wonder how much flash this has. Memory. Okay, storage, SPI flash, PS RAM. Ooh, what does that mean? Crap. Does that mean it's 8? I'm in over my head. In over my head. I guess this PS RAM is not what we need, right? This is it. 4 megabyte SP flash. This is the flash memory. That's the hard drive equivalent. So it's 4 megabytes. Okay, great. Let's go back to the command line. I'm going to type this in by hand because that's how real men do it. ESPtool.py -P, and then my port, which in this case is COM21 -B, and then we'll just use what they say here, 46. Read flash 0 is where it starts, and then it goes to 0x, and then in this case I want 4 megabytes. So I'm going to go 4000000. Got enough zeros? Yes. And then I'm going to make a file called TTGo cam.bin. Okay. What's the worst that can happen? Hey. That's awesome. So this is important because you can do the same thing with any other ESP-based device. So an ESP8266 device like a Sonoff, or even something with Tuya on it, or of course with an ESP32 like one of these camera modules. Very handy. Okay, it looks like we're done. Let me find that file just to make myself feel better. Oh, there it is. TTGo cam bin. So if I wanted to reload that with ESP Home Flasher or the Node MCU Flasher PY or whatever, I can. Yes, excellent. Now that I know how to do this, it's easy. So you install Python. Python will install in a folder. You open a command prompt, navigate your way into that folder so that you're, C:/ whatever, and you're in that folder where Python lives. Then do the pip install ESP Tools. That will install the ESP Tools where you need it. And then you can run these commands. You can run all these ESPtool.py commands. Why was that so hard for me? Sometimes it's hard being dumb. We've now successfully backed up the firmware, so I'm pretty comfortable with going ahead with the flashing of this little board with ESPhome and Jenny's setup. So let's do it. Okay, I've got here a gist that contains the YAML code that Pinky Wafer created that got her TTGo camera working. So it's available here. Anybody who wants to grab it, I'm going to grab it and copy it. Copy. Open up VS Code and start a new file. Paste all this in there. And we're going to save it as TTGo Camera.yaml. I do want to put it in the folder where all my other ESPhome devices live, and that's here. Save it there. I like this part. I didn't know you could do substitutions like that. I just never looked into it, but that's pretty cool. That'll save some time. I'm just going to rename some of these things. Now I'm going to take out the IP address. I'm not going to do the manual IP address. Password is named differently. It's just Wi-Fi and then Wi-Fi PW. That's what I call mine. And then I don't need this manual IP address. Shouldn't. Should work without it. There's two buttons. This one here is actually labeled IO34. So we can set this button to do something different. This is the reset button. So that's going to be already fixed to whichever pin number the reset pin is. But we can give this button on the right side here whatever function we want, I assume. Sweet. Font. We can change the font later if we want, but we're going to leave it for now. This is the SSD1306 display. So this will be fun because this part, this lambda here, is where we might be able to do something different in the future with a little bit of creativity and get some other things to display on that display. I think that's it. I think I'm ready to save this. We open up Home Assistant and we go to ESPhome. It'll be interesting to see if it shows up. TTGo camera. There it is. Edit that just to see it. Let's try and validate it. Dang. ESPhome fonts Times New Roman. Okay. The easiest thing to do is probably just to find this. This is a great way to get a virus. Put this here. ESPhome fonts Times New Roman TTF. Done. Now let's try that again. Validate. Yeah. Just needed that font in the right place. We're ready then for compiling first because this is fresh install. We have to compile the binary and then load the binary onto the board. When the binary's finished compiling, you'll get this successfully compiled program message. Download the binary to someplace where you know where you can find it. Now to upload it, I could go back to using ESP Tools, but the ESPhome flasher is just too easy to use. Port 21, browse, we're going to find our firmware. TTGoCam.bin. Open that sucker up and let her rip. Bye-bye, original flash firmware. Erasing flash, this may take a while. Time for a snack. That really didn't take long at all. Now with this still connected, you start to get some output from the board. It's grabbing images. You can see it says got image and it gives you the size. Then you can see the PIR state on and off. So it must be sensing my movement and sending it on and off. I want to press this 34 button. Okay, so there's the TTGo Cam button. I press that and it goes state on and off. So that's something I can use later. So very cool. Now, let's go see about putting it into Home Assistant. So for new ESPhome devices, you have to go to Integrations. Oh, what? All right. Yeah, so I had to hard reset. So unplug, plug back in. Now there's a new discovered ESPhome device on the integrations page. So configurations, integrations, new device, configure. Do you want to add it to the TTGo to Home Assistant? Yes. Do I want to put it in an area? I don't know where it's going to be yet, so I'm not going to add an area just yet. Now I should be able to find the camera on the states page. TTGo, look at that. There's the button, there's the PIR, there's the status, there's the camera feed. There it is. Hey, camera feed. Hi. Hello. Wonderful. So we've got a button, got the PIR, got some basic information, but most importantly, I've got the camera image. Let's watch that PIR change. Oh, there it goes, PIR to on. Sweet. And then the button press to on. Very responsive. Love that. That's how we'll trigger the doorbell for sure. We'll just make that button the doorbell button. And we've got the time and the date. Sweet. Well, what made this so easy was, once again, support and help from the community. From Pinky Wafer, but also, of course, from Odo and all the guys that work so hard on ESPhome to make it so compatible with so many things. We're almost done with the doorbell. The next thing we got to do is put it in some kind of enclosure. If you know me, then you know my first choice is going to be to 3D print something. When I'm looking for a 3D model, I go to Thingiverse. A quick search for TTGo camera, and I got this model pretty quick. I printed this one out and tested it, and what I liked about it was that it fit pretty nice. This mounting system is really cool also. But in the end, I ended up designing my own. This is the one that I made, and it's almost the same as the one from Thingiverse. The two big differences are this little hole is over the reset button. This model has a big hole, so somebody could press that button easier. And since this is going to be in a place where there's going to be a lot of little kid fingers, I'd rather not have them pressing the reset button all the time. So I made the reset button accessible, but not easy to get to with your finger. The other thing I did was extend this button here. So it's just an extra piece that extends this button out. With this model, you had to kind of push in to get to that button. And I wanted this to be easy for the kids to push with their fingers. And when you put the case on the top, it just pops through enough that makes a real nice, easy, clickable button. And that's it. If you still don't have a 3D printer, a good alternative would be a soap dish like one of these. Now, if you need to get them from Amazon, here they are. That's 3 for $10. If you just go to Walmart, they've got them for like $1 a piece. I've actually used these for several projects, and they work really well. They fit everything really nice. They've got a nice latch. If you wanted to, you could waterproof them with some silicone. Just a great little project box for $1. Just drill the right size holes in the right places, and you can fit your doorbell in this. Now, the last thing to do is to set up the automation so that it'll do some fun stuff when somebody presses the button. This is the automation that I'm using. The trigger will occur anytime somebody presses that button that's attached to GPIO34. The action is to call the service that sends a text-to-speech message to the Amazon Echo in the girl's room. And it says, "Knock, knock, someone's at the lovely beautiful's door." That's what I call my girls, the lovely beautifuls. My two littlest girls spend a lot of time on a particular iPad, and so I installed the iOS app on that iPad and set it up as a different user so that I could use the notification service to send them messages. So for the doorbell, I want them to get a notification that says someone's at their door, and it shows them the image from the camera. So that's the automation that I think the girls are going to use the most. But I set up another automation that would take advantage of the motion sensor on this TTGo board. This automation is triggered when the motion sensor goes from off to on. I set a condition so that this automation is only active between 11 p.m. and 5 a.m. What I'm trying to do here is figure out if somebody's out of bed wandering the halls in the middle of the night. If they are, then I'll get a notification on my phone, and my wife will get one on hers. With these two automations, we've got a pretty good doorbell. We can get an image if there's motion detected or if somebody pushes the button. I think that covers pretty well what we want out of our doorbell. And I think that's about it. Must be time for the demo.
Knock, knock. Someone is at the lovely, beautiful store.
Well, that's it. The TTGo ESP32 Camera Board as a doorbell in Home Assistant. Comparing this one with the other ESP32 camera board that I turned into a doorbell, the advantages here are this one has the PIR sensor and the push button and that cool display. The one thing that this board is missing is the ability to use one of the GPIO pins as a touch module. It's probably still possible, but I couldn't find an easily available GPIO pin that's capable of functioning as a touch sensor. I really like the touch sensor stuff. I like that more than the mechanical button. But overall, with the PIR sensor and the display, this TTGo board is pretty solid. I still have 3 more ESP32 camera boards to review. If you want to see more videos about projects like this, I've made a ton of them. And if you want to chat with me or other people who also like projects like this, check us out on Facebook or Discord. And in addition to doing videos, I also do live streams at least once a week, usually on Sunday mornings and then some random weekday whenever I can squeeze it in. Well, that's it. As always, thanks for watching. Till next time, adios.